Okay, this is the force diagram for the quarter laying on the surface. The quarter's mass is 0.00567 kilograms, and in order to find the force of gravity, you plug into the equation Fg equals mg, having m equal the mass of the object and g equals the acceleration of gravity. When we plug it into the equation, we get that force of gravity equals to negative 0.0556227 newtons. And since the object is not moving, the normal force and the force of gravity must be equal. So therefore, or they must equal 0. So therefore, the normal force is 0.0556227 newtons, or positive 0.0556227 newtons. This is the force diagram for a quarter sliding off the surface of a board. And we want to find the values of each force, so we make the force diagram simpler and only include one angle for the force of gravity. First, we set up our x and y table. We don't know what the normal force or the force of kinetic friction is yet, so we leave it as this. But we know that since there's an angle and we know the force of gravity already, we just multiply the force of gravity times sine of 300 degrees. Right here, and force of gravity times cosine 300 degrees for the x and y components. In order to find the normal force, the force of gravity and the normal force must be equal 0, since it isn't falling down or going upwards. So you plug into the equation and you get that the normal force is equal to 0.04817 newtons. Then you do the same thing for the kinetic force, except this time you use the x component for the force of gravity, and you can find that the kinetic force is equal to 0.0278 newtons. This is the force diagram for a quarter moving at constant speed across the table. The quarter's mass remains the same, and the force of gravity and force of the normal force remains the same as well. But this time, whatever tension force you put on it, the force of kinetic friction will be the same since it's moving at constant speed.
You're not even pulling.
Okay, this is the force diagram for the quarter being pulled in two directions by one string on one side and two strings on the other side. So, since there are two strings here, and it's still the quarter is still at rest, these two must add up to equal to this based on this equation right here. And the normal force and the force of gravity must be equal to each other so that it doesn't move at all. So we know that quarter mass is still the same, and the force of gravity and normal force is still the same. But this time the equation for the tension force is different. So we have force of tension 1 plus force of tension 2 plus force of tension 3 to equal 0, so it stays at rest.